On this example, we're looking at a right triangle, and we're given two pieces of information about this triangle. We know an angle, A is going to be 15 degrees. So I'm going to put 15 degrees as I'm sort of labeling this. And we also know the hypotenuse this time, which is going to be 9. So I'll put it on that side. Also labeling this, we have our opposite side and our adjacent side. If we're focused on A being 15 degrees and using that to find each of these other ones. We can also go ahead if we want to and say, oh yeah, this is the hypotenuse on this side. Okay, so the easiest of these three other pieces of information together is going to be angle B, the capital B there. So angle B, we have to remember that all the angles in a triangle have to add up to 180 degrees. So if we start with 180 degrees, we subtract off the 15 degrees that we know, and then also the 90 degrees, because it's a right triangle. What we're going to end up with is 180 minus 15 minus 90, which is going to leave us with 75 degrees. So we can go ahead and plug in 75 degrees. I'm going to go ahead and put it down here as my answer as well. All right, from here, we still need to find our two other leg lengths of this triangle, little a and little b. To do so, what I'm going to do is I'm going to use SOHCAHTOA. So when we think about SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. What I would probably do is, because I know the hypotenuse that was given to us, I'm going to use either sine or cosine. And you can focus on either the 15 degrees or the 75 degrees. I'm choosing to focus on the 15 degrees just because that was initially given to us. So if I want to find A, that would be the opposite involved with the hypotenuse. So that would be sine of 15 degrees is going to be our opposite, A over the hypotenuse, 9. So we have an equation where we want to find what A is. We just need to get rid of that dividing by 9. So I'm going to multiply both sides by 9. Therefore, canceling those out, and that'll put A on one side all by itself. So we have 9 times the sine of 15 degrees. Now you could get an approximation for this if you wanted to. Put it in the calculator, make sure you're in degree mode as opposed to radian mode, and you shouldn't have any problems doing that. Next, let's go ahead and try to find B. All right, this is 9 times the sine of 15 degrees, by the way. Not a very nice number, but not a super difficult problem to solve down either. All right, so if we want to get B involved, that's the adjacent to 15 degrees, and we already knew the hypotenuse. So the adjacent is going to be cosine of 15 degrees will be the adjacent, B, over the hypotenuse. And then again, very similar as far as solving down, we'll multiply both sides by 9 to get B on one side all by itself. So we get 9 multiplied by the cosine of 15 degrees. And there we have a nice exact answer. Again, get the calculator out if you need an approximation. But I hope this helps in helping you understand right triangles a little bit better and using SOHCAHTOA and trigonometric ratios. Good luck to you with it.